Hello and welcome everyone to the June session of the Purdue Technology Alumni Speaker Series. My name is Nick Haywood and I'm a 2006 graduate of the School of Aviation and Transportation Technology. The Alumni Speaker Series is a joint collaboration between Purdue Polytechnic Institute and the Purdue Technology Alumni Board. The purpose of the Purdue Technology Alumni Board is to support the efforts of Purdue Polytechnic Institute, formerly known as the College of Technology, facilitate communication between the school and its alumni, provide programs for professional growth, and enhance alumni relationships with the university and the Purdue Alumni Association. To learn more about the Purdue Technology Alumni Board, please use the Get Involved link on the Alumni and Friends page of the Purdue Polytechnic website. The Alumni Speaker Series is a monthly series created as an opportunity to engage technology alumni on topics that have broad interest to the alumni base. The presenters for each session will be technology alumni or Purdue Polytechnic faculty. If you're interested in participating in a future session or have suggestions for topics for future sessions, please email techdev@purdue.edu with a brief synopsis of the proposed presentation. The only guidelines for the proposal is that the topic is of broad interest and the presenter is an alumnus or faculty member of Purdue Polytechnic Institute. Today's session on cloud computing is being presented by David Purkey. David is a 1983 graduate of electronic engineering technology with over 20 years of IT experience as a system integrator, system administrator, application developer, and cloud infrastructure automation engineer and consultant. Currently, David serves as the cloud architect for worldwide technology in Nashville, Tennessee. Welcome, David, and take it away.
All right, thank you very much. Here, let me go ahead and share my screen, and let's get started. I am going to go through the presentation, and I've asked, I'm going to have a question and answer session at the very back, at the end. So if you can hold your questions until then, that'd be great. I may have slightly too many slides to go through, so I might have to run through this a little quickly. Today, I'm going to talk to you about what is the cloud and why should I care? We already talked a little bit about myself. I'm a Purdue alumnus. I have over 20 years of IT experience in a vast array of different industries. A fun fact for myself, I was a member of an a cappella group back in the day, and we performed on many stages, local, regional, and even competed nationally. So, we'll get down to it. Everybody has heard about the cloud, I'm sure, in the media, whatever. But what is it? A few years ago, a salesman once told me that if somebody says they understand the cloud, they're trying to sell you something. Actually, I think has changed a lot. I hope to leave you with an understanding of what the cloud is and what it's not. So let's think of it as a Cloud 101. Since there is a lot of details that we can go into, it's going to be a very high-level conversation. So when we're talking about the cloud, there's really only two broad types that we're talking about. We're talking about cloud compute and cloud storage. Let's keep those in mind as we move forward, and let's get into this. First of all, well, Wikipedia says that cloud computing is an on-demand availability of computer system resources, blah, 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 blah. You can all read. This is, quite frankly, a sad definition and not that helpful because this really describes all of modern IT. Wikipedia also goes on to say that cloud storage is a model of computed data storage in which digital data is stored in logical pools. This definition is better, but it can also be applied to cloud compute. Now, we start going down a rabbit hole here because Wikipedia also states that the cloud was invented in the 1960s by a man named Licklider who was working on something called the ARPANET. And, well, to me, this is kind of like saying Benjamin Franklin invented the telephone, or that the automobile was developed in the 5th century by the Greeks because they made the first wheelbarrow. This really comes from the group of people who really think that the internet is the cloud, and the cloud is so much more than just the internet. Now, speaking of ARPANET, for those who don't know, ARPANET was developed by funding of the United States military to connect previous isolated islands of compute structures throughout basically the United States. It really is the birth of the internet. They were the ones who created the IP protocol, which, by the way, as in many things in IT, is kind of redundant because the IP protocol actually stands for the Internet Protocol. And once the military had outgrown ARPANET, that's when it turned over to public use and became what the Internet is, as we say today. I really want to point out at this point that Purdue University played a key role in the Internet since before the Internet even existed, and way, way before Al Gore coined the term International Informational Superhighway. So just a step back just a second here and look at a brief history of computing and how we got to the cloud. I mean, computing itself has been around for a long time. Mechanical computers were developed really in the 17th century by a couple of gentlemen who created these essentially adding machines that worked in our native number system, the base 10 number system, which of course is the fact that we work with numbers that go from 0 to 9. And it was very complex, very difficult things to maintain and to operate. And also at about the same time, mathematicians in Europe started studying something called binary or base 2 systems, which were a much simpler form of mathematics that, when these two fields finally came together, gave us modern computing. So as we evolved in the cloud, we started off with mainframes. I'm sure pretty much everybody's heard of a mainframe. They allowed shared access between concurrent users, but all local resources, and they all share the same operating system. I think this is a fundamental building block of the cloud. The next one is, of course, ARPANET, which allowed the same shared access between concurrent users with the local resources, but also gave them remote access to other computers. Of course, desktop computers came along in the 80s, which offered some low-cost computing available to offices down to individual users. These, of course, grew into servers, which allowed for greater power, multi-using, multi-threading, and then local area networks, which allow small computers to talk to each other within local areas, and then branch out to larger areas. And as the IT matured over the years, a financial model grew out of that, also known as more traditional CapEx or capital operating systems, which is where companies needed to estimate what the amount of IT resources they needed up front, pay that money up front, and then hope that it covered all their needs. And at this point is when IT actually had to start always playing catch up, because it's very difficult to estimate what needs you're going to have, and once you outran those needs, how do you happen to what do you do after that? You know, operational costs started to climb. Operating system, maintenance cycles. Talking about operating system patchings, they found that these could actually kill an application, and they found that any change at all could end up killing an application and hurting the business. So this is where the idea of if it runs, don't touch it started. So you have servers out there in a data center that, quite frankly, after years of running, they don't know exactly what's running on it, and they are afraid to turn it off. So it must always be running. The turn of the millennium, 1999, a company of VMware started, and they produced the very first virtualized desktop services, basically allowing servers to run multiple copies of themselves on the same hardware. Because what they found is that even though these servers were fast and powerful and they could serve a lot of users and perform a lot of functions, at the machine level, these servers are basically doing nothing most of the time. It takes longer for the screen on your desktop to refresh than it took to run the entire program. So the researchers out of Stanford University formed a company called VMware, which then allowed hardware to run more than one server all concurrently. Now, this sounds a lot like mainframes, and you're right. It is a lot like mainframes. Mainframes did that at the very beginning. The only real, not the only real difference, but the real difference here is that in virtualization, you can run more than one operating system. In mainframes, it was one operating system. Everybody had a copy of it, and everybody ran the same, basically the same operating system, and it was Unix. Now with virtualization, Windows could run along right next side to Unix, share the same hardware, and really utilize the hardware much more efficiently. More recently now, something called containers has shown up on the horizon, and these are very similar to the virtualization. They share the same operating system, very similar back to mainframes. But the difference here is they can run in a virtual machine, or they can actually run on a standalone server with no difference between hypervisor or type of virtualization you're using. This plays a key role in development of what we know now as the cloud, because now you can take an application and run it on essentially any virtualization service on any server anywhere at any time. I'm sure some, if not all of you, have heard of the word Kubernetes, which is actually Greek for the word governor. This is a system that allows containers to run anywhere at any time. This is actually a project that came out of Google and allows an application, like I said, to run virtually anywhere, anytime, on any hardware. So the public cloud was born essentially in 2006 when Amazon released what they call the Elastic Cloud Compute, or EC2, in, like I said, in 2006. They built out a series of virtualized data centers that has now stretched the globe. And more importantly, they created a control plane to automate these operations. And then they started renting out compute space. Legend has it that AWS came about because of the Amazon bookstore grew so fast that they had to build out the infrastructure for it to allow for all shrinking and growing of demand, and then saw a market opportunity and rented out the excess capacity. This is almost true. Amazon had a side project that they were building out a massive e-commerce system that they were going to rent out to other retailers. It turned out that once they experimented with their own infrastructure, that they kept it to themselves and built out what is now known as AWS, or Amazon Web Services. They were the first to market and still the leader, and adding new services very quickly, almost daily. Google and then Microsoft followed in periods of 2-year increments after that. Google took a completely different path to market. Google first came to be known for their search engine, and most of their capacity was built out in support of that search engine. They made big strides in what is now known as big data. They developed big data tools and then released them open to the open source. Things like Hadoop, Hive, Pig, and Spark were all developed by Google engineers and then released to the market for free of charge. Microsoft followed in 2010, expanding their own technology out in the cloud. Now, some people might say that not a whole lot of groundbreaking stuff happened there. If you look at Azure, you'll see everything that you'd expect from any kind of Windows service. So, cloud types. There's actually a few different types that you may hear these words. Private cloud, this is a term that some people will argue about whether it's actual cloud or not, but I think it's a key point because it includes virtualization, it includes the control backplane, whether it is in-house or at a co-location, is still really, when you think about it, is really a private cloud. Public cloud, or somebody else's computer, are the things like what I was talking about before, Amazon, Google, Azure. Now, there's two types that are becoming more and more prevalent, hybrid and multi-cloud. Hybrid cloud experience is really extending your private data center and network out to include a single public cloud provider, where a multi-cloud is essentially a hybrid cloud, but you're going out to many different ones. And what does that look like? I mean, you can have your on-premise data center with a mixture of physical servers, virtual servers, however. You could have a co-location, which is your virtual machines running in someone else's space and connected to a single cloud. A multi-cloud, of course, is the exact same configuration, but you're going out to different clouds. And there's a key difference between those two, really about how the company expands out to that. And I'll get into that a little bit later, but just to know the difference between hybrid and multi-cloud at this point. What I think is one of the key differentiators of what cloud is the services they provide. And there's a number of acronyms that you'll hear. These are all the different types of services that are currently being produced and provided by various cloud providers, as well as internally. The very first one is known as IaaS, or Infrastructure as a Service. That's the on-demand compute, networking, and storage. And this is really what a private cloud would be about. You have infrastructure on demand. You have virtualized servers that can be spun up within minutes to provide compute. You attach it to storage and attach it to a network. Software as a service, or SaaS, is something else that I'm sure everybody's heard a lot about. These are all basically applications that are available on a subscriber basis. Salesforce is a big example of this. TurboTax, Google Maps are also one. They provide specific services via their software, whether it's an ERP system, whether it's a human resource management system, or a GIS, geographic information system, pardon me. You'll hear of PaaS, which is platform as a service, which is essentially everything a developer needs to go and develop a application and deploy that application into either a cloud or into private servers. A new service that is becoming much more popular is NAS, or Network as a Service. In the old days, when you have to add computers to a network, there's a lot of physical patching, a lot of plugging in of cables into switches and routers, programming those routers to route that traffic. NAS is virtualizing that service so that those networks can be configured within moments via software. Then, of course, database as a service is one, and it's very popular and gaining a lot of traction, which is, of course, as I said, database as a service. You can rent time on a Oracle instance, SQL Server, Postgres, MySQL, pretty much all of those and more are being supported by all cloud providers. And then there's everything as a service. That's pretty much the other category. When you start talking about mobile applications, Internet of Things, which is really all the smart components out there, they're even putting computers into refrigerators to tell you when you're running low on things. That's all part of the interconnection of Internet of Things. So getting back a little bit about what is the question? We still haven't really answered what is the cloud, have we? Microsoft has a little bit better definition about this, that the cloud is not a physical entity, which is true. It is a vast network of remote servers around the globe that are hosted together and meant to operate as a single ecosystem. I like this definition, but it still falls short because it doesn't address the fact that the cloud is really an aggregate of services, not so much servers, not so much physical entities. I like the definition for two reasons. One, because I think it's better, and two, because I said it, is that cloud is that it is turning enterprise IT operations into services, not servers. And the cloud actually separates the physicality of the service away from the server. No. Of course, we may know who is the cloud. Everybody's heard of AWS. Everybody's heard of Google and Azure. But there's a lot of other players out there that you may or may not have heard of. And the other two large ones are Rackspace, which started out as a co-location facility, but has moved into more managed services. And of course, Alibaba, which is growing at very fast pace over in China. Gartner research in cloud usage has provided some pretty interesting data. They predict by the year 2021 that there will be a convergence of sorts, where 1/3 of all enterprise computing will be done on premise, 1/3 will be in the cloud, and 1 will be in off premise. And when they say off premise, they're talking about in a co-location, some kind of managed service like Equinox, like I showed in my previous slide, or previously Rackspace. But this graph also shows that there is a trend that more and more compute resources are moving out of house. They will not disappear entirely because some workloads are much more are more suited to run internally versus externally. There will be more co-locations that will platform out, and then cloud providers will continue to grow, but I also see that they platform out around 2024 and beyond. So why the cloud? You will often hear a version of this statement. It's everything is cheaper in the cloud, or we can go to the cloud because it's cheaper. We will only pay for what we use. Well, yes, you will only pay for what you use. But if you start it and forget it, you will pay for it forever. And what this means, yes, you will get past paying money up front, but you'll be paying ongoing maintenance. So when thinking about going to the cloud, you must be careful. It is not a simple question, nor is it a simple solution, as I'll get into here in a moment. You also hear the argument of capital expense versus operational expense. Capital expense, which means that you buy a bunch of hardware up front, where operational expense is the expense of monthly, keeping the lights on, like power, water, and air conditioning. Well, my friends, it's a trap. Well, maybe. Question here is, will switching which pocket you take the money out of really help solve your problems? In the short term, yeah, maybe. Because you're paying smaller amounts per month. But what about long term? If you have big dollar amounts every 5 years but what about a smaller amount that runs for 20 years? You really have to think about long term when we start talking about the cloud. As if you switch to an operational model for your expenses, you're treating it like utility, such as keeping the lights on. But does that mean you have to keep all your lights on all the time, forever? So really, why to go to the cloud? You need to shift your focus towards the business. If you're going to make IT become a utility, which makes sense because businesses don't need to generate their own electricity. You don't need to provide your own water. Do you really need to provide all of your IT infrastructures? IT used to be an innovative force in business, but is becoming to see more of a diversion from the core aspects of the enterprise, especially in small startups where they don't have the capital to build out a data center before they even have a product. So the key of this is really a transformation. You hear other stories or other things such as you go to the cloud so you can move at the speed of business, which I think is a total misnomer. Let's face it, successful businesses don't change. Once they got it right, they stick to it. 20 years ago, IT was a major driving force in business change. It caused businesses to fundamentally change things how they do. It disrupted everything. However, IT is continuing to change, but businesses have lagged. Why? If you're successful, if it's not broken, don't fix it. But we're finding out that the business's old ideas about IT was actually slowing them down. And the cloud represents an opportunity for business to regain that ability to change at a quicker pace and to capitalize more on the market changes. Because the market's changing, business or not, somebody loses out. And you do that by fundamentally transforming your operations. I like this slide in many ways because I have heard every one of these reasons for going to the cloud. And I'm not exactly sure that any one is less valid than the other. But if you go from the very bottom left here, we're going to the cloud because the CEO said to. It's probably not the best reason, but not necessarily the worst reason. Really want to look at the upper right here, increase scalability and increase reliability. The concept that if, for example, you're an e-business and your retail business spikes after Black Friday, if customers come to your site, overloads it and crashes it, you lose money. The cloud allows you to scale the size of your infrastructure for the time periods where you need it and scale it down again when you don't. That increases your reliability, and it also gives you a chance to become more agile and innovate more and faster. Considerations are going to the cloud. Unfortunately, going to the cloud is much more than just getting an AWS account and telling your developers and your business people to have at it. There are a whole bunch of number of aspects to consider to avoid causing other problems by fixing either other problems. And this graphic really shows how a good foundation will help you build out a very successful cloud journey. And then governance, if you don't have governance, you don't have any guardrails put around what people can do and when. You don't have a strategy for going to that cloud, especially if you're going to multiple clouds, because each one is slightly different, and you could be creating a situation that's much more complicated and more difficult to manage than you had before, and as well as security. Security is key, and is one of the biggest reasons for not going to the cloud. Security, data sovereignty, intellectual property, all these things are very valid concerns, and they really come down to the same point. Who has access to what, when, and why? Traditional IT security has turned enterprises into fortresses. I mean, years of building up solid, secure firewalls that are impenetrable to attacks have now been turned on their head. The advent of cell phones, Internet of Things, they have to open up holes in these walls, which are causing problems. More problems, concerns is more a better put it, for security people. It is forcing the industry to look at more robust and fluid defenses. General George S. Patton, a very colorful individual and controversial for those who don't know. He revolutionized mechanical warfare in World War II. Speaking about tank warfare, he said that fixed fortifications are a monument to the stupidity of man. And that is playing out exactly that way in IT. That hardware firewalls that are set to block specific traffic and that does not change based on usage and traffic patterns are bound to fail. Today's cloud providers have invested heavily in not only cutting edge security and privacy, but in developing new systems for privacy and security, well beyond what most enterprises have been doing or even capable of doing. They combine robust access controls with in-depth monitoring by leveraging things such as automation, artificial intelligence, and machine learning. The result is that your presence in the cloud can be more secure than any of your data centers. I say can because while the cloud providers help, they do not provide all the security that you need. You must have a strong IT presence in your house. Otherwise, you're open to all kinds of different things. The cloud providers, like I said, the cloud providers help. They provide the state-of-the-art tooling and monitoring, but in the end, it's still up to the enterprise. In addition, there are many countries around the world that have enacted laws for protecting data that state that a company's data cannot be physically taken out of the country. So, cloud providers have worked around this. They've built out data centers literally around the world. And as an end user, you can specify where your data resides, where it computes, and where the compute happens. Not only that, but as a provider to your end customers, you can specify and move your data closer to your company, to your customers. Things like data latency, network latency is a big issue, especially if, again, back in e-commerce. You want your customers to have the fastest response time as possible. So you can physically move your compute and your content physically closer to your end users. So a U.S. company who has a big customer base in, say, the EU can actually have points of presence in the EU. Even though your data is in the U.S., you can serve up static content and compute resources in the EU, which then communicates back to your data. This increases your reliability and availability because you're literally spreading out your resources around the world to put them closer to your companies, to your customers. So bottom line here is, if these points are not covered, do not do it under any circumstance. This is a concept that is becoming more and more prevalent amongst application development, but it is spreading out into modern IT across the world. The idea that modern IT is a three-legged stool. It is more than just technology. It's more than just your people. It's about processes as well. Any one of these legs fail, the whole system fails. But I put process on the top here because, in my mind, that is the most important. It might be because I started off my professional career as a process development engineer, but be that as it may. What we have found that if you change your technology, change your people, but don't change your processes, a world of hurt awaits. If you do the same old, you're going to end up spending lots and lots of money. So what kind of process controls are we talking about here? There's a few here listed here. First of all, to be successful in the cloud, automating your IT provisioning, compliance, and governance is key. I mean, because things are moving faster, people are doing more things more quickly and going in different directions at all the time. IT needs to be able to create approved workflows for these end users within your business, for your developers. Make sure that they are doing things within company policy, within regulatory policy, to ensure that the resources you're consuming are actually is usable, right, and are maintainable. That if resources are developed for short-term use, that they're actually turned off when they're not needed, because you don't need cost. You don't need to be paying for things you don't need, which gets us into the cost controls in the center column here. You're paying by the minute for everything, which makes companies have to think about the concept that servers are fungible. That means they can go away. And this, my friends, I think is the hardest thing for businesses to wrap their head around. Going back to the concept that, when it runs, don't touch it. You might break it. The idea here is that you don't have to upgrade your operating systems anymore on existing applications. With the cloud, you can create a brand new copy an exact duplicate of your production environment, put a brand new copy of your application on it. And by the way, this new copy has got all of its operating system patched up to the highest level. You don't have to change anything. You create everything net new. The old stuff, once it's tested, you take the test system, turn it into production system, and you shut the production system down. That is a radical concept that a lot of IT people have been having a problem with. Also, reporting. You need to leverage the cloud providers and third-party providers' resources for keeping track of what you're doing and project what you'll be needing in the future. Then, of course, there's the whole aspect of DevOps. I mentioned this earlier, with application development happening faster and more frequent. Traditionally, applications are upgraded maybe once, twice a year. For good reason, because operating systems have to be upgraded, new software comes out. But what they've done in the past is create all these big changes and roll them all at once. A concept now called DevOps, which is really the bringing together of development and operations, allow you to write your code, build your app, test your app, release your app, all in a very fast pace. Because with going back to the automation, if something fails in production, you have an automated process in place that can roll back to the previous version instantaneously. There is no more downtime. By this whole cycle of application development has bled over into the whole application environment of the cloud itself. You'll often see this this loop when they're talking about DevOps and computer, and this is very complicated. I know this, and DevOps started out and still is as much a philosophy as it is a process or a tool set. But the real downside of here is there are many tools out there that can help you along this journey. And of course, the paths to the journey. I mean, there are so many different ways to the cloud. Not one size does not fit all. There is no set process you need to go through. It really depends on your company. I mean, you'll hear things like lift and shift, which is really just moving existing workloads from your data center out to the cloud. This works with some applications, and it is a terrible idea for other applications. You have to pick and choose which ones you can use for this. The things you'll hear, things like serverless or cloud native, which is really refactoring your application, rewriting it so that it can run in a parallel fashion. Most applications are not designed to run on multiple machines at the same time. So refactoring is included. Serverless is a concept where you're running your application. All you have is code. You don't stand up a virtual machine in the cloud. You just let the cloud run it. Every cloud provides this type of service, and it's something to look into. But again, it takes a complete and radical change in your software. Really, what you need to do is a concept we call land and expand and transformation. It means you pick the applications that are easiest to move and then expand from that. Taking everything all at once and moving it is really a bad idea. You need to, just like in the DevOps cycle, you build, you test, you repeat. Now, to do this, most companies can't do it on their own, but there are a lot of companies out there who can help you on your journey. But the key point here to remember is to pick one that understands your needs, your business, and who have done it before. And when I say done it before, who actually do more than just give you a plan. Always beware of those companies out there who will give you a roadmap and say, see you later. Because it's good to have a roadmap. A roadmap is fundamental. It lays out how to get there. But most companies don't know how to implement that roadmap. If they did, they would have by now. So you really need to go with a company or a group that have done it before and can stick with you, not just give you a plan, but help you actualize that plan as well. Which now leads me to my brief moment of selfless and shameless self-promotion. I work for a company called Worldwide Technology, and we are probably the biggest and most successful company that you've never heard of. In fact, 20 years in the industry, I never heard of them before I started working for them. If we were publicly traded, Worldwide would be sitting right in the middle of the Fortune 500, but we're not. We're a publicly held company, so that's probably why nobody's heard it. We're not on the stock market. We don't have that kind of exposure. But what we are is we are an industry leader in data center hardware build out and refresh. We supply data center hardware, pre-configured hardware around the globe. And we've been doing this for close to 15 years. Recently, we've been developing and building out a cloud practice because a lot of our customers have been wanting to go into a hybrid or multi-cloud environment, but are struggling to do so. So we have built out a cloud practice to help them do that. We have partnerships with the big three cloud providers. And while I say that, the really key point of that is that we are not going to push anybody towards any particular place. We help our clients achieve their goals, their stated goals, not our goals. So with that, I would like to open up the mic to questions, comments, suggestions, jokes, funny stories.
Hey, David, this is Nick. So one of the things that I think about whenever I think about this transformation is the tool sets of the people necessary to develop in the cloud, are those different than kind of historical models of how or the skills that people have whenever they did development?
I won't say they're different, they're extensions of it. Right, because the tool sets the development tool sets now are expanding to include things like parallel processing. Here, for example, most web applications are meant to be they are called stateful applications, which means that they remember what you've done. If I go into if I log into a website and say I want to do this, this, and this, the site, the server remembers what I did, so you can go back and do that other thing, do what you did previously, right? Well, with cloud, either serverless or cloud native applications, they are built so that they can be handed off to another server if the load increases, and so that gets a little problem with maintaining that state. So your first click, your first screen could be in a server in, say, San Francisco. Due to the load, your next click could be in a server in Washington, D.C. So those two servers don't know exactly what you've done before. So the application has to be changed so that state information is stored somewhere else. So the new tools that are developed, because that has to encompass those things. So the answer is yes and no. I mean, the application development is similar to what they've done before, but the tool set is growing and expanding.
Thanks.
Certainly.
Hey, David, my name's Tim. I have some questions around, those applications that aren't cloud native. What tools, either in the data center or outside of the data center, do you think really enable businesses to run a quality hybrid cloud environment that you speak of? Thinking of things like software-defined, hyperconverged infrastructure, et cetera.
That's actually a really good point. Now, applications and infrastructure are run hand in hand, but they don't necessarily aren't necessarily linked anymore. I talked about containers earlier. Containers is a way of making the application completely portable. They can run on any infrastructure anywhere, whether it's hyperconverged, whether it's running on VMware, running on Xen hypervisor, running on bare metal. They are completely encapsulating the application itself. The only thing it shares is operating functions from the operating system of the running virtual machine or environment. I'm not sure if that really helps your answer or not, because when you start talking about hyperconverged and applications, it's really the mismatch between compute resources and storage resources, right? As long as those two are working properly, a well-defined application doesn't care. Now, well-defined application is a huge caveat, right? So that encapsulating those into a container then really completely removes it from the underlying infrastructure. I mean, we can go deeper into that. I mean, get more specifics, but at a high level, I think that's what the answer there is.
Nope, I appreciate the perspective. Thank you.
Mm-hmm.
Any other questions? All right, thank you, David, for sharing your wealth of knowledge today, and thank you for our attendees for joining us. We'll hope you join us for our next session of the Alumni Speaker Series in July. Dean Gary Bertolini will share an update on the state of Purdue Polytechnic. Just note to check back on the Speaker Series website soon for the date and time. We had some recent scheduling challenges with the Dean, and a new date and time is being worked out. But that'll be communicated via our regular channels as well as updated on that website. And then on August 20th, alum John McDonald will present an overview and primer of the Internet of Things. To stay connected to the Alumni Speaker Series, please bookmark the Alumni Speaker Series page using the link from the Alumni and Friends page on the Purdue Polytechnic website. Thank you for joining and have a great day.